Hello, today we are going to look at the structure of the atom, but we will dedicate today's lesson to the history of the discovery of the structure of the atom or the atomic theory. The fact that the atom consists of protons, neutrons, which are located in the atomic nucleus, and electrons revolve around the nucleus, this idea of the atom did not appear immediately. It was preceded by a number of historical aspects to which we will pay attention today. So, to begin with, in 430 BC, the Greek scientist Empedokles imagined that matter could have the state, this is air, this is fire, this is earth, and this is water. Around 400 BC, Democritus, a renowned Greek scientist, put forth a groundbreaking theory regarding the constitution of matter. He postulated that matter is composed of minute particles called atoms. This concept at the time was considered quite peculiar. It was commonly believed that atoms could be acquired through the careful splitting of wood until a state was attained where they could no longer be divided any further. The understanding of how these atoms interconnected was equally unconventional, as it was thought that atoms resembled balls with loops or hooks that facilitated their connection with one another. So the idea of the atom and of substances, of molecules, was very simple. Now let's move on to this year. English scientist Thomson discovered, with the help of his multiple experiments with cathode rays, the first particle is the electron. It will be recalled that the electron has the designation now generally accepted, and it is shown thus. It was noted that the electron is extremely small and has a negative charge. In pudding in general, a pudding model appeared, in which the idea of the atom looked like the idea of a pudding, where the pudding was regarded as a general quantity, where the nucleus was a kind of porridge of this pudding, and the electrons were wedged into this pudding like, say, a raisin, which we can put into an ordinary pudding. Then at the same time, the Japanese scientist Nagaoka suggested that the atom might have a model that resembles the Saturn planet. You probably know how this planet is organized and where the nucleus is located. The nucleus of the planet can be likened to the nucleus of an atom, while the electrons that spin on the same ring of the atomic structure resemble the known ring of the planet. This view of the atom was prevalent at the time. However, in 1911, scientist Rutherford made a groundbreaking discovery. He found that the nucleus possesses a positive charge. This was determined through experiments involving the bombardment of gold foil with alpha particles. The behavior of these particles revealed their positive charge, as some passed through the foil while others were deflected at various angles or even thrown back. Hence, Rutherford concluded that the nucleus is conventionally located at the center of an atomic particle and possesses a positive charge. This positive charge causes the alpha particles to be repelled by the nucleus particles. The assumption, therefore, was that the nucleus carries a positive charge. In 1913, Niels Bohr furthered the understanding of atomic structure and suggested that the atom was organized as follows. Inside the atom there was a nucleus, which had a plus charge, and electrons revolved around the nucleus. With this came the famous Bohr theory, which states that electrons can be in certain stationary and non-stationary orbits. Moving from one orbit to another, an electron can emit energy or absorb it. Then at the same time, the scientist Moseley suggested and proved by calculations that the positive charge of the nucleus coincides with the atomic number of the chemical elements. For example, if hydrogen has an atomic number of 1, then its positively charged nucleus has the same charge plus 1. Next, in 1919, Rutherford discovered the particle protons. Protons are particles that have a positive charge, and they are in the nucleus, so the nucleus has a positive charge as well. In 1926, Schrödinger suggested that the model of the atom has a wave corpuscular model, meaning that particles can have two kinds of properties. They can move as particles, hence their name corpuscles, and in addition they have motion in the form of a wave. For example, as a wave they create a phenomenon that you know as interference, and diffraction is a manifestation of the mechanical corpuscular theory. In the year 1932, Chadwick discovered another particle that is in the atom. This is the neutron particle, and this particle was found to have a charge equal to 0. That is how this particle came to be neutral, hence its name. Then, at the same time, Heisenberg clarified that the nucleus, which sits at the center of the atom, has the following composition. It contains protons and neutrons. Note that Bohr first assumed that the nucleus is composed as a single unit and has just a plus charge, but Heisenberg established that the nucleus contains the particles protons and neutrons. Protons are plus, so the nucleus has a plus charge, and neutrons have a charge of 0. Electrons, on the other hand, revolve around the nucleus. An intriguing proposition was made in 1948 by Meyer and Jensen regarding specific orbits in the atom. They proposed that the structure of the atom closely resembles a tiered system with particles, mainly electrons, occupying and traversing distinct levels. This led to the development of the level theory, which suggests that conventional floors or levels exist within the atom, accommodating the distribution of particles. Later in 1950, Reinvoter confirmed that the current model we are working with is the most substantiated. According to this theory, the atom comprises a nucleus positively charged due to the presence of protons and neutrons, whilst the electrons orbit in designated orbits or levels. These electrons exhibit an uneven distribution, with some being located closer to the nucleus compared to others that are farther away. The behavior of these electrons during their movement within an atom is extremely intricate. Comprehending the mechanisms by which electrons navigate the atom is of great importance in the realm of chemistry, as it extensively impacts the chemical properties and characteristics displayed by each element. This well-established theory requires no further elaboration and remains as the solitary substantiated explanation. But I would like to say that there are other particles in the atom in the nucleus. They are no longer called elementary particles, but smaller ones. But the nucleus, from the point of view of chemistry, is not so important for us to determine its characteristics very precisely. That's what physicists do. But for chemistry, it is the composition of the nucleus, protons and neutrons that is important. But the most important role, of course, is played by electrons, on which depend the characteristics of the element, physical and chemical properties, on which we can assume in what chemical reactions these substances, these elements can enter. Goodbye.